Welcome back. We're in Vectors and Projectiles, worksheet number 1, problem number 2 out of Giancoli here. An airplane is traveling 785 kilometers an hour in a direction 38.5 degrees west of north. Oh, interesting. Find the components of this velocity vector in the northerly and westerly directions. And how far north and how far west has the plane traveled after 3 hours? Cool, great. First, let's go do the cardinal coordinates, the cardinal plane here. Remember that north is up, south is down, west is usually to the left, and east is to the right there. Now, it's not always like that, because if you were like, in the northern hemisphere looking down towards the southern hemisphere, it would be like, backwards for your point of view. And that's why we always list that, because it isn't always the same. Anyways, that's how it normally is. So let's go ahead and list this vector here. It's 38.5 degrees west of north. So I'm going to do that exactly as it says. So I start at north, and then it says I'm going that many degrees west of it. Well, west is to the left there, so I'm going to measure out 38.5 degrees that way, and then my vector must be right there. Cool, that's how that works. If you've never done that before, it's that simple. You just literally start drawing exactly as it says. Kilometers per hour. Great. Now, you might say, is that too fast for a plane? And I'd say, no, that's actually kind of a slow-moving plane. I wouldn't say slow, but medium-paced, I would probably say. If you were traveling on like an international flight, you could be going 600, 700, 800 miles an hour. Kilometers. Kilometer is a shorter unit than even a mile. So anyways, moving on. Find the components in the northerly and westerly direction. So again, it doesn't matter which side of the triangle you draw these component vectors on. I'm going to draw them over here. But you'd have the x direction here, or the west direction, clearly pointing west, and the one north clearly pointing north. Now, notice that my angle is 38.5 degrees here in blue, but that's going to be different down here in the little bottom right-hand corner of that triangle. Instead, this one is going to be the 38.5 degrees up there. Okay, cool. Now, I could similarly go over to my calculator and go, oh, that's just 90 minus 38.5, and get that this is 51.5. And that would be equally correct. I'm going to go ahead and use the 51.5, because why not? Similarly, instead of doing these green ones here, I could have instead done these purple ones right here, and the purple one right there, and said, hey, there's the northerly bit and the westerly bit, and that's equally correct. Don't do both, just do one. Well, actually, in P1, I did the green one on that side. So I'm going to go ahead and do the purple ones here, and I'll keep it color-coded as purple so you can follow along here. So we, as from class, we recognize that, hey, the one that's adjacent to it, it's right next to that one, that's going to be using cosine. If I take the hypotenuse, multiply it by the cosine of that angle, we just simplified that a little bit, and that's that whole side right there. Similarly, and I'm kind of running out of room there, I shouldn't have made this way up here. Similarly, this top one here is the hypotenuse times the sine, since it's the opposite side of 38.5 degrees. And so that's how big the northerly and westerly vectors are. Let's go ahead and let's list that out, though. I'll list it as V sub west, and V sub west will be the 785 sine of 38.5 degrees. I grab my calculator, you are 2, and I get 488.67, 488.67, and that is in kilometers per hour. An hour is just abbreviated, that H there. And the V sub north, you could say, is the 785 cosine of 38.5 degrees. And I grab my calculator once again, you are as well. And that's 614.35 kilometers per hour. Somebody asked me, hey, do you always just round it to 2? And I'd say, well, there's a specific way to round, and that's called significant figures, and we're not worrying about them in this course here. So round to something that's reasonable, 2, 3. It depends on what numbers you have there. If you get something that's 0.000, then some non-zero numbers after that, yeah, don't just round to 2 and say it's 0. Do something reasonable, and you won't have a problem. But look up sig figs. Significant figures is the best way to do it, the correct way to do it, and really not that hard, but we're not focusing on that for this class, this course. Anyways, find the components of this velocity, did that, how far north and how far west has the plane traveled after 3 hours? Well, check it out. It's this many kilometers per hour, so if I go and I take these things, and let me do that in a different color here. Well, let's not do green because I did green up there. So I'll do, no, I already did purple. Blue is the original vector. Oh my gosh. And I can't do green, I'll do brown. Okay, brown's safe. And if I go and I take this and I multiply that by 3 hours there, that's 3 hours over 1. The hours cancel out there, and I'm left with kilometers there. And that totally works. And so I multiply that by 3 hours as well, and the units cancel out, and that's exactly how that does work. And so if I multiply that one by 3, I get a 1,843.04 kilometers there. And make sure that you're not rounding beforehand, but you're only rounding at the very final answer. And when you do that, you get 1466.02 kilometers. Boom, that's it. All right, that's it. Have a wonderful day. See you. Bye.